Hello, math students. Welcome back to our module called Linear Equations, and this is Lesson 8, Linear Equations in Disguise. Our goal for today we will learn how to solve equations that are not obviously linear equations. The question that I want you to think about in this lesson is, how do you solve an equation that is built out of fractions on both sides? All right, so the thing that I want you to do is go ahead and start by looking at the review problem that we have right here. And it says, let's review. You have x fifths equals 6 twelfths. The first thing that we're going to do when we're looking at this equation that we have sitting right here is we need to ask ourselves, is this a linear equation? And if it is, then how do you solve it? So one of the things that we always are trying to find out is whether the equation is linear and nonlinear, because if it's linear, then that means that we can solve where x will either have one answer, no answer, or infinitely many answers. And so that's what helps us determine finding the solution is if we can see that it's linear. By looking at this, our variable is in the numerator position, and it goes to the power of 1. So by that idea, that's telling me that this is a linear equation. So then the next thing that we have to do is we have to figure out how to solve it. And what you're doing when you're solving a linear equation is you're trying to isolate the variable or get x by itself. So in order to get x by itself, what you have to do is you have to think about what's happening to it. So right now, we have a variable. It's being divided by 5. So if we take our standard BU chart and identify the steps that it took to build it, then we could see that our variable is x. It's being divided by 5. So in order to get that x by itself, we would multiply both sides by 5, and we would be left with x. So if we try that, then we have x divided by 5 equals 6 twelfths. So what it's telling us to do in the BU chart is multiply both sides by 5, and when we do that, we have to do 5 over 1, because 5 divided by 1 is still 5, so it doesn't change the value. And then we would end up with 5x divided by 5, and then 5 divided by 5 is 1, and x, and then 1 times x is x. So we end up having x by itself, which is what we're supposed to do. However, when you're working with an equation, what you do to one side, you have to do to the other, so we multiply this side by 5. So we're going to multiply this side by 5 over 1. So then 6 times 5 equals 30, and 12 times 1 equals 12. And then we can simplify that from there, and I would say divide both of them by 2, so you get 15 sixths, which we can divide both of those by 3, and then we would get 5 halves. So we now know that x, let me move it over here a little bit, equals 5 halves. So now you were able to find the solution for this equation by understanding what's happening to the variable and then working backwards, okay? So that's basically all that you have to do whenever you are trying to isolate your variables. So if we want to take a look at the next one, we'll see if we would use the same way. Something that we need to look at for this one, however, is that it looks a little bit more complicated because this time we have variables on both sides of the equal sign, and they're happening in the form of fractions. This one says x minus 1 divided by 2 is equal to x plus a third divided by 4. So immediately my brain is going, well, there's x's on both sides, so in order to solve them, we're supposed to get the variables on all the same side, but the problem is that they're having an additional step that's happening to them. So in order to isolate them even further, then what I have to do is the opposite operation. So right now, I'm going to focus on this side first. So if I make a BU chart just for this side, then my BU chart would look like this, and my variable is x. The first thing that I'm doing to it is subtracting 1, and then I'm dividing by 2. And the way that I know that is because the subtracting 1 is actually attached to the x first, and then I divide it by 2. So to undo that, then I'm going to multiply by 2. Eventually I'll add 1, and then I should be left with x. So if I do just this step, I want to see what we will notice. So I'm going to multiply this side by 2 over 1. What you do to one side, you have to do to the other. So then I would get 2 times x is 2x, 2 times a negative 1 is negative 2, and then 1 times 2 is that. So then I have 2x divided by 2, which would give me 1x, and negative 2 divided by 2 would give me negative 1. And so now I just have x minus 1. So that wasn't so bad, right? Because all I had to do was simplify those out. And then on the other side of the equal sign, I have 2 times x, which would give me 2x, and 2 times 1/3, which would give me 2/3, right? Because I have 2 of 1/3, which would be 2/3, right? All over 4, right? So now what I have on this side is x minus 1 equals 2x plus 2/3 all over 4. Okay, so that looks a little bit easier, but I'm still having this issue of having the divided by 4. So now I am going to change colors just so that I can get you to change your focus, and I'm going to make a BU for dealing with this side. So my BU on this side would be, okay, my variable is x. The first thing I did to it was I multiplied it by 2, then I added 2/3, and then I divided by 4. Okay, so to work backwards, I would multiply by 4, then I would subtract 2/3, then I would divide by 2, and hopefully I would be left with x. So we're going to look at this piece right here. So it tells me to multiply by 4 over 1. What you do to one side, you have to do the other. So I'm going to multiply by 4 over here. Okay, so then here I get 4 times 2x is, I'm going to write it over here so you can see it. 4 times 2x is 8x, plus 4 times 2/3 would be 8/3, right? And then all of that divided by 4. So 8x divided by 4 is really 2x, right? Plus 8/3 divided by 4 is the same thing as multiplying by 1/4, which would give me 8/12, right? So I have 8/12, divide both of them by 4, it simplifies to 2/3 again. So I really have 2x plus 2/3, which is what we have. And then what you do to one side, you have to do to the other. So then over here, I get 4 times x equals 4x, and 4 times a negative 1 gives me a negative 4. So now what I'm doing to finish it is I have 4x minus 4 equals 2x plus 2/3. So that's not so bad, right? Now I can finish it up and see what we get. So we're trying to get our x's on the same side. So let's get our x's on the same side by taking minus 2x from both sides. So that creates a zero pair. This would become 2x minus 4 equals 2/3. And now I could do my finalized BU chart, which is right here. And I have x is my variable, times by 2, subtract 4. So I need to add 4 to both sides, divide by 2, and I'll be left with x. So now let's take a look at it. And so we're going to take plus 4 to both sides. And I remember what we did in class the other day, where if I change this to thirds, that would be easier. So that's really actually 12/3. So 2/3 plus 12/3 equals 14/3, right? So now my equation says 2x equals 14/3. Okay, so now it says that I'm supposed to divide both of them by 2. So divide this by 2, and dividing by 2 is the same as multiplying by 1/2. So now I have x equals 14/6. And so I've now figured out what x equals. All right? So yeah, that was a lot of steps, and I should have left myself more room. I apologize for that. But we did find x. So one of the things that I did mention early on is that once you found x, it would be a really good idea to plug it back in to see if it works. So x equals 14/6, which can also be equal to 7/3, which I would like to use instead. I just simplified it by 2. So now I have 7/3 minus 1, which is actually 3/3. All of that divided by 2 should be equal to 7/3 plus 1/3 divided by 4. So let's see if that works. So 7/3 minus 3/3 is actually 4/3 divided by 2 equals 7/3 plus 1/3 is actually 8/3 divided by 4. And then if we multiply because this really says 4/3 divided by 2, which is really 4/3 times 1/2, right? Which equals 4/6. And then this one is really 8/3 divided by 4, which is the same as multiplying by 1/4, which would actually be 8/12. So does 4/6 equal 8/12? And the answer is yes, because all you have to do is divide both of these by 2, and you get 4/6 equals 4/6, which is a true story. Okay, so you were able to decide that x would equal 14/6 or 7/3, and they came out balanced, being 4/6 is equal to 8/12, because you can simplify those to 4/6 equals 4/6. So our value of x did work. Okay. All right, so then if we are going back to where we were looking, it said on our original, or if we look at this one, 5/12 is equal to x6 is the same as 5 times 6 equals 12 times x. And the reason that we know that that is true is that if you go back up here and look, what was the first step that we did? We multiplied both sides by the denominator. So if we multiply this side by the denominator, what you do to one side, you have to do to the other. So we multiplied this side by the denominator. And then if you fast forward over to here, in order to get this fourths off, we had to take times 4 over here, right? So we multiplied by this denominator, and then we multiplied it over here by the same denominator. So what we're saying is, if you take the number that is on either side of the equation and we multiply it by the denominator of the other side, then you will come up with the same answer. Okay? Now this is true as long as the denominator is not 0. If the denominator is 0, then it won't work. As long as the denominator is not 0, then you can multiply the numerator with the other denominator. Okay, so if we were going to look at this again, if we have 5/12 equals x6, then if you're looking at how to get rid of this one to get, or let's get the variable by itself, right? You're looking at this one, then the first thing on our BU charts would be multiply both sides by 6. So I'm multiplying both sides by 6, and when I do that, I get 6 x's divided by 6. 6 divided by 6 is 1x, and then x times 1 is x. So as you can see, that side worked. So now let's do this side, and you get 6 times 5 is 30 divided by 12, right? And then what they were saying is that what you can do is if you have 5/12 is equal to x over 6, they're saying that all you have to do is take the denominator and multiply it by the numerator of the other side. So we would actually get 5 times 6, which equals 5 times 6, which equals 30, and then 12 times x, which equals 12x. And does this equal that? Well, if you finish it off, you have 30 equals 12x. We would divide each side by 12, and we would get 12 divided by 12 is 1. 1 times x is x, and then you get 30 divided by 12 as your answer. Does 30 divided by 12 equal 30 divided by 12? The answer is yes. So that's how you can prove it both ways. Okay? So either way, I would like you to try, if you want to stick with the BUs, because that's what we were doing, and you can do 2 different BUs with 2 different colors so that you can keep track of it all. That would be a great idea. Okay? It's completely up to you, however you're feeling comfortable with doing it. My most important thing that I can suggest is that you go slow, step by step, until you've unbroken all of these parts that are being connected. So we divided by 2 on both sides first to get rid of that guy. Then after we did that, we divided by 4 on both sides to get rid of that guy. And then when we finally did that, we got down to here, where we combined all of our like terms, got the variables all on the same side, and then our last BU is where we were able to work all the way through to finish it. Okay, so going back to our goal for today we will learn how to solve equations that are not obviously linear equations, which we just saw, and then how do you solve an equation that is built out of fractions on both sides. Basically, the way you do it is you're just trying to undo what it says that it was happening to it to begin with. So whatever is your variable, build an undo chart to tell us what you were doing with your variable, and then undoing it will successfully allow you to isolate it and then figure out what the final answer would be. Okay? I know it seems really complicated, but again, deep breaths, step by step, working through the BU to isolate your variables and get them by themselves, so then you can get them all on the same side and then finally solving. Okay? All right, kiddos, that's all I have for you in this lesson. I'll talk to you soon. Bye!